Here in this problem, we have to design DFA for the following three problems or the alphabet A, B. What is the first problem? String shall contain even number of A's. That means if you take a string consisting of A's and B's, the number of A's shall be even number. In the second problem, string shall contain odd number of A's. That means the number of A's in the given string shall be odd number. And the third problem is number of A's in the string shall be divisible by 3. That means if you count the number of A's in the given string, that will be divisible by 3. Suppose if you take any string, suppose B, A, B, B, A, B, B. Suppose how many A's are there? 1, 2, 3. There are 3 A's. 3 is divisible by 3. When you divide 3 with 3, what is the remainder? If you divide 3 with 3, the remainder is equal to 0. That's what we have to understand. The number of A's in the given string shall be divisible by 3. Suppose if you take B, A, B, A, B, B, A. Here 1, 2, 3, 4, 5, 6. The number of A's are 6. 6 is divisible by 3. So the remainder is equal to 0. That means we have to design the DFA where it checks whether the number of A's in the given string are divisible by 3 or not. Now we will solve one by one. The first problem is string shall contain even number of A's. So what is going to be even number of A's? If A's are 0, then also even number. If A's are 2, then also even number. If A's are 4, then also even number. A's are 6, then also even number. So on. Irrespective of B's, here we are not talking about B's anywhere. B may come anywhere, anytime, any number of times. There is no consideration of B. Here the question is concentrating on number of A's. Here the number of A's shall be even. So here epsilon is also, here 0 is also an even number. So we will show 0 as epsilon. 0 as epsilon case. That means if suppose if you take the language of strings, the language of string shall be L is equal to epsilon B A B A. Here even number of A's. P A B A B A even number of 1, 2, 3, 4 even number of A's, so on. But the minimum string is epsilon. By epsilon we are not talking about B. If 0 is considered as an even number, then the minimum string is epsilon. So now your initial state will be your final state. If no input is there, then your initial state will be the final state. Now what happens if you have 1A? If you have 1A, it is not accepted. You are going to state Q1. If you have another A, that means for this A, I am pairing another A. This is going to the reverse direction to the initial state. So this is first A and this is second A. If you have another A, this is third A and this is fourth A. So for every even number of A's, we are coming to the initial state. That is now here the final state. But in between, you may have any number of B's. We will not care. We may have any number of B's. Suppose B comes, you are not worrying about. B comes, you are not worrying. You are looking for A. Okay, 1A comes, you are going to the state Q1. Again, B, you are not looking at B. You are not looking at B. You are just skipping. Another A, yes. So for this A, the pair comes. For this A, another A is there. Now again, you are coming back and you are staying at Q0. Suppose if you see B, you are skipping. Again, another B, you are skipping. Suppose if you see A, and you are coming to the state Q1. And you are looking for pair. That means you are looking for another A. If another A comes, then again you are coming to the initial state. So now this is the way of designing the DFA for accepting the strings which are having even number of A's. Here, even number of A's means you have to concentrate on A's only. You will not worry about B's. Why? Because here we are not discussing about B's. You may have any number of B's. B may come at any time. Now the next problem is string shall contain odd number of A's. Odd number of A's is minimum A is 1 and 3 and 5 and 7, so on. Irrespective of B's, B's may come at anywhere. So what is the language of string? The minimum string is A, BA or AB, AB, AA. That means odd number of strings. A, B, A, B, A. Odd number of strings. 1, 2, 3. So on. You can form any number of strings because it is a infinite long ways. So now for the minimum string Q0, on Q0, if you see a single A, that is it is an odd A, so you are going to Q1 and you are making the Q1 as a final state. After 1A, you can have any number of B's. Before A, you can have any number of B's. Suppose if you see another A, then you are coming to the initial state. That means this is first A and this is second A. Now if you see another A, again you are coming to the Q1. That means A. That means this is the odd number of A's. That is acceptable. So here, suppose if you see another A, again you are going to the initial state. Suppose if you face another A, then you are coming to the Q1. That is the final state. So for every odd number of A's, you are coming to the Q1 state. Or if for every even number of A's, you are going to the Q0 state. Here, if you see like this, Q0 is the even state. If you see Q1 is the odd state. So now this is the way of designing the DFA for the strings which contains only odd number of A's. Here also we are discussing about the number of A's, but not the number of B's. B may come 0 times, B may come any times, B may come anywhere in between A's. But we are continuously concentrating on the number of A's. If it is odd number, then we are going to Q0, Q1. If it is an even number, we are coming to Q0. Now in this problem, the number of A's shall be divisible by 3. That means when you divide the number of A's with 3, the remainder should be 0. This you can show it as a modulus of WA. A means the number of A's. Number of A's shall be divisible by 3. So here, if we have 0 number of A's in the given string, suppose you have B. Here there is no A. That means A's are 0. 0 is divisible by 3. That means 0 number of A's is accepted. Suppose if you have 3 A's, then also accepted. Why? Because 3 is divisible by 3. If you have 6 number of A's, then also it is accepted. That means divisible by 3 means A's may be 0, A's may be 3 times, A's may be 6 times, A's may be 9 times, so on. And in between, B may come anywhere. A, B, A, B, A. Here A comes 3 times, so the string is accepted. B, only 2 B's. In here there is no A. That means A comes 0 times. So 0 is divisible by 3. So now it is also accepted. So that the minimum string is epsilon. Here we are not, if we don't consider the B's, only A's, then epsilon will be the minimum string. Next, A, or combination of AB's, BA, A, or BB, A, B, A. Here 3 A's, here 3 A's. Like this you can form an infinite long ways. So now if we see a epsilon, then your initial state will be your final state. That means if 0 number of A's are there, then it is accepted. It is accepted. Suppose if you see another 1A, you are going to Q1. If you see another A, you are going to Q2. That means how many A's comes? This is first A and this is second A. Now if you see another A, then you are coming to the initial state, that is your final state. So A. So this is third A. 3 A's means this is for first A, this is for second A, and this is for third A. That means 3 A's. That means 3 divisible by 3. Suppose if you see 4A, you will be here. If you see 50A, you will be here. If you see 60A, again you will come to the initial state. That means for every A's which are divisible by 3, you are coming to the initial state, that is final state. Suppose for A's 0, 3, 6, 9, you are coming to the initial state. Suppose if I have a string A, B, B, A, B, A. How many A's are there? There are 4 A's are there. In between you can have any number of B's. So you can have any number of B's. We are not worrying about B's. Suppose I have a string B. So here initially on Q0 you will be on the Q0 only. Next A you are coming to Q1. Next B you will be on the Q1 only. Next B you will be on Q1 only. Again you see another C, another A, again Q2, again another A, again you are coming to the initial state Q0, and again B you will be on the same state. Again you have seen another A. So when you see another A, you are coming to Q1 and you are stopping here. Why? Because the string is ended. Is Q1 is acceptable? No, it is not acceptable state, because the number of A's are 1, 2, 3, 4. 4 is not divisible by 3 and you are getting the remainder 0. So it is not accepted. So for every number of A's which are divisible by 3, you are going to Q0. If it is not divisible by 3, then you will stuck at either Q1 or Q2. So this is the way of designing the modulo related string operations. Here the number of A's shall be divisible by 3. That means if you divide the number of A's with the 3, then the remainder shall be 0. So for such type of problems, you have to design the diagram like this. Similarly, if it is 4, you will have one more state. If it have 5, you will have one more state. But the concept is same. I think you're all understanding the problems. Here I'm giving the clear idea of how to design. What are the aspects behind in designing the problem? How you have to take the string cases? What are the possibilities of string? Then how to design the diagram. Okay, please watch the video more number of times so that you will understand clearly. Thank you for watching this video. Thank you all. Thank you for watching this video. If you really like this video, please subscribe, like, share, comment on my YouTube channel. In future, we are going to create many more videos on computer science engineering subjects. Thank you.